Okay, let's launch the class. Let's launch soil fertility. So what you see on the screen here in front of you is Unit 1, the introduction to this class. We're going to focus on yield limiting factors and essential plant nutrients within this unit. And there are several learning objectives. You'll notice this throughout the semester that each unit has a set list of learning objectives. And those learning objectives are there for you to prepare for exams and to obviously learn soil fertility. In this unit, there's 5 learning objectives. And in units 1 and units 2, I sort of hand walk you through each one of the objectives. And then as we progress through the semester, I don't do that anymore because there's just so much information. But regardless, what you need to do to prepare yourselves for the exams is to understand the learning objectives for each unit. So let's start. So the learning objectives for Unit 1, the introduction, is, or are, you should recognize soil fertility issues with the many factors affecting crop productivity or plant productivity. Understand Liebig's law of the minimum. It's highly important for soil fertility. You should be able to identify the 17 essential nutrients for plant growth and whether each one is a macronutrient or a micronutrient. There's actually several more, but they're not needed by all plants, and we'll touch on those briefly. But we'll touch on these 17 elements specifically throughout the semester. The 4th learning objective for Unit 1 is to identify the criteria used for establishing whether an element is an essential plant nutrient. And this is in this unit because some plants, in fact, most plants take up most elements or nutrients, elements out there in the soil, for example, lead or cadmium, and they're not necessary for plant growth, but nonetheless, plants take them up. And then the last learning objective is to describe the relationship between increasing or decreasing plant nutrient concentration on plant yield with respect to both nutrient deficiency and toxicity. And so what we're going to do first is go through some relatively important definitions. So number 1, we're taking a soil fertility class, or all of you are. So what is fertility? Fertility is simply the ability of an organism to reproduce. And so soil fertility takes a twist on that definition. And this definition, and there's many definitions with respect to what soil fertility really is, but it's the ability of a soil to sustain plant growth and to bring that plant to a reproductive stage by supplying essential plant nutrients and water in adequate amounts. So not too little and not too much. That's the target we're shooting for in this class. Okay, there's several other definitions that you should be aware of. Fertilizer. What's a fertilizer? A fertilizer is a substance. It can be chemical, it can be natural, that when added to a soil increases soil fertility, right? So it increases the ability of soil to sustain plant growth and get that plant to a reproductive stage. So why do we need fertilizers? This, I hope, is relatively obvious. I'm sure most, if not all of you, have applied a fertilizer to some plant or crop in your lifetime. And why do we need fertilizers? The main reason why we need fertilizers, and you probably can answer this yourself, but the main reason is because the soil is lacking in a particular nutrient or nutrients, and thus we apply fertilizers to meet those nutrient demands. This is why we apply fertilizers. So the next question is, well, what's the difference between a fertilizer and a soil amendment? And they're distinct, okay? And so many of you likely have used fertilizers and many of you likely have used amendments. A fertilizer simply improves soil nutrient availability, or the ability to supply nutrients to a plant. An amendment is much more than that. An amendment certainly improves soil physical conditions, such as soil-water relationships, holding capacity, infiltration of water, maybe soil structure, and it may also add nutrients, right? Sometimes amendments don't, or they add them at very low concentrations, and sometimes they do. So a good example would be manure. Manure has plenty of nutrients, nitrogen, phosphorus, potassium, and it also has organic carbon, which can lead to aggregate stability or improvements in aggregate stability, which improves water relations in soils. And another amendment would be something like biochar, all right? A biochar that was made from woody biomass like lodgepole pine. Plenty of carbon, very little nutritive value, but it actually may improve water relationships. And so when we combine all these definitions together, soil fertility management, this is what you're here for, to learn about how to manage soil fertility. And so the definition of soil fertility management is simply a suite of practices adapted to local conditions to maximize nutrient and water use efficiency and to improve productivity of crops or plants.